Okay, so again, good afternoon, everyone again, and I hope you had a few minutes to grab a coffee or a cup of tea, and welcome back to what is the last session for today of our seminar, which is dedicated to the launch of the Ontology Explorer, which is a new tool to extract and analyze ontologies for non-citizens' identities, and which is one of the most recent research outputs of the Processing Citizenship project. Let me first of all briefly introduce our speakers. I'm sure, well, you all know Analisa, Pelizza, but for the few of you who have maybe just connected now, Analisa is Professor of Science and Technology Studies at the University of Bologna and visiting professor at the University of Twente, the Department of Science, Technology and Policy Studies. And importantly, she is the principal investigator of the ERC project Processing Citizenship, of which you have already heard today. Wouter van Rossem is a doctoral researcher at the University of Twente. He's also working in the same project, Processing Citizenship, and giving a fantastic contribution to the project, I must say, thanks to his background in applied computer science and his previous experience as a software engineer, and his expertise on data interoperability and data quality. And we are also very happy and honored to have with us as discussant today Professor Aldo Gangemi, I hope is, yes, great, who is Professor of Computer Science at the University of Bologna and the Director of the Institute for Cognitive Sciences and Technologies of the Italian National Research Council. He has worked and published extensively on semantic technologies, and we are therefore really pleased that he has accepted to discuss Analisa and Wouter's work today. So yeah, Analisa and Wouter will give a presentation of around 30 minutes, and then I will give the floor to Professor Gangemi for the discussion, and then we will open the floor for questions from the audience. For those of you who are following us on YouTube, remember that there is the chat box on the right side of your screen where you can raise questions, you can write your questions, and we will read them and I will ask them to the speakers. So yeah, I give the floor to Wouter or Analisa. I don't know who is starting first.
Yeah, well, thanks. I can start with an introduction to the Ontology Explorer, its context and its goals, and then Wouter will more describe the tool and the method in more detail. So, and then Aldo, hi. We will be happy to discuss with Aldo Gangemi this experiment. We've been talking about experiments and tests today. So I just repeat one of the main threads of today's discussion, and as the seminar as a whole, as the ability of methods for knowing populations to shape and even to enact those same populations they claim to represent. And this is surely true of methods to know people who cross borders, which is the topic of processing citizenship. Let me share with you my presentation. So such methods to know populations that usually rely on digital databases against which border officers check whether the person who's trying to enter a national or supranational jurisdiction is already recorded, and why. For example, border officers might want to exclude that someone entering the country has already asked asylum in one of the European Union member states and is now asking asylum in another. Such databases are developed at the national level, like the case of the CIA system in Italy or the Register of Foreigners in Greece, or at the European level, which now counts 3 databases most used at the border, Eurodac, VIS, SIS2, plus other databases like Europol, by Europol and Frontex, like IORA, and two systems under development, the ATS and the entry-exit system. We've seen a few of them this morning during the presentation by the analog. So we at Processing Citizenship are aware that such a databases don't limit themselves to represent people who reach the border, either with or without the required documents. We know that it is those databases that make people a migrant, a visa traveler, an asylum seeker, or even a criminal. So I can tell you the story to give an example of a woman whose registration I followed at the Turkish-Greek border. This is also close to one point that was raised by Norchimaris before. So the woman passed the river Evros with her family, and not having the documents, she was brought to a registration center and was registered into the Greek database. During registration, she was asked about her profession, and which was school director. So the problem was that the asylum officer couldn't find neither school director nor teacher in the scroll down menu of the register of the system, as these professions were not provided for. So other intellectual professions were accounted in the scroll down menu, but not school director, neither teacher. So as a consequence, the lady's profession was registered as other. And I suggest that that was the moment in which, at least for European authorities, the lady stopped being a school director and became a migrant. That was because her profession was not part of her identity anymore, at least not in the way her identity was recorded in a European system. So this is an illustration of how databases perform identities, how they enact population and don't merely represent them. Databases can enact populations in two ways. One is by making assumptions about people. For example, the CIS2 database that is used to verify that those who are crossing the border are not criminals. Well, it requires to indicate whether someone is aggressive, as if aggressiveness is a constant, immutable trait of personality and not a reaction to a specific event. So SIS2 assumes that aggressiveness is a constant trait of people. But databases can also enact populations by not providing some categories and attributes, that is, by silencing them. And this is the case of the Greek database that didn't provide an option for school directors nor teachers. What we were discussing this afternoon, thanks to the work by Adele Clark about situations. So we see how classification systems and ontologies embedded into databases are crucial to analyze how populations are enacted. The semantic analysis of ontologies is one of the main goals of the Processing Citizenship project. We aim to analyze how border crossers are enacted in Europe as irregular migrants when they are caught at the border and they are registered in national and European databases. And we also aim to see how diverse authorities running diverse databases enact populations in diverse ways. More about this in a minute. But in order to conduct this analysis, we have developed a method, a web method and a tool, which we have named the Ontology Explorer. The Ontology Explorer is a method combining existing software and web tools in novel ways. It is novel as an integration of insights from early infrastructural studies on classification and their extension to data and metadata-driven infrastructures. And Wouter van Rossem will explain the functioning in detail in 5 minutes. But before that, let me discuss 3 principles of the Ontology Explorer as a methodology. The first principle is that the Ontology Explorer is taught to conduct an analysis of the data models, which are the formal encoding of an ontology in a technical artifacts that are used in the databases. So data models allow reconstructing the ontologies, which are the discursive model of a domain. So we consider such ontologies a meta layer of data for the observer, which can reveal the assumptions that are made about people, like the example I gave before, the permanent character of aggressiveness. And they can also reveal the possibilities that are excluded by design, like in the case of the school director. Using a vocabulary derived from actual theory, we say that through this method, it's possible to apprehend how people are inscribed in information systems. The second principle concerns the comparative nature of the analysis that can be conducted thanks to the Ontology Explorer. With respect to ethnographic analysis that is said to be thick, we can, on the contrary, say that data models that we analyze can be extremely thin. We have categories and attributes, potential categories and potential attributes that don't appear to hold much meaning. We might have nationality as a category, and we might have a set of attributes of different nationalities among which to choose. We might find a full list of professions, like in the case of the Greek database, and see it as complete. And indeed, there were intellectual professions like painter and sculptor in the system. So categories and data models, they might be very thin, they might not be super meaningful. It's only when the officers run into a school director that the exclusion becomes evident. In other words, meaning emerges from comparison. The meaning of categories and attributes stems from their presence in some databases and lack in some other databases, or lack with respect to actual use, like in the case of the school director. So this is why the Ontology Explorer was thought to support the comparison of data models between different databases, like SIS2 and Eurodac, but also between national and European databases, like the Greek and Italian database on one hand, and Eurodac, VIS, SIS, ECIAS on the other hand. One of our leading questions indeed asks how national and European authorities differ in the way they enact migrants. So this sort of comparison that the Ontology Explorer supports allows achieving the second key goal of process and citizenship, which is following how the enactment of people at the border entails in parallel the enactment of polities like Europe. Thanks to the ability to see that a thin attribute like school director is included in a database but excluded in another one, the analysis of ontologies reveals authorities' own imaginaries about foreign nationals or people on the move. Think, for example, at a system that, at the database that asks for language, so has a category language, and a database that distinguishes between native language and spoken languages. In the first case, people are considered monolingual. In the second case, they are considered polyglot. And this talks about the imaginaries about people by the diverse authorities who design systems. So a method that analyzes data models used in diverse databases is able to compare the imaginaries of diverse authorities about people on the move. And these authorities can lie at different scales, like in the case of European Union, when we have European agencies and member states. So as I said, a similar analysis is helpful in studying the co-production of people and polities, especially when it comes to the division of labor between member states and agencies in the European supranational system. Finally, the third principle of the Ontology Explorer is that it allows accounting for resistance. if we adopt the jargon of ANT, the analysis of ontologies through data models reveals imaginaries, or what we could call scripts of intended people, so assumptions about people crossing the border. Yet actual people crossing border can adapt to such assumptions, as well as they can resist or describe them. And this comes closer to this distinction between politics and populations that we were discussing before. We think that by looking at the scripts of intended people can ground the analysis also of how actual people react to them. To give you an example, this is I witnessed the case of 17 persons that crossed the border in Sicily and declared to be siblings when recorded on the Italian system. And of course, that was a way to contest the Western understanding of family, what I called categorical stretching, so contesting the meaning of a category, in this case, the category of family. So producing scripts analysis of intended people allows conducting further ethnographic research, where practices of resistance exerted by actual people emerge as a contestation, not in a vacuum, but a contestation of our authorities, ontologies, data models, and classifications. So these are the three principles and goals that we kept in mind while designing the Ontology Explorer. And now I'm leaving it to Wouter van Rossem to illustrate the method in more details. Thank you.
Okay, thank you, Analisa, for that introduction. So, try to share my screen. Do you see my presentation without the presenter notes?
Yeah.
Okay, yep. Okay, so yeah, very happy to present this method and tool we've developed, which we call the Ontology Explorer, and how we use it to investigate these relations between information systems, data models, and their, say, world-making potential, how they enact people. So as Analisa mentioned, in general, we focus on the semantic classifications to identify people, so data models, and that these data models allow reconstructing, let's say, ontologies of a domain, which in the case of protein citizenship is migration border control. This is grounded also in assumption about the politics of data models design and how some information represented becomes visible or consequently invisible. And our method should thus make visible these assumptions and possibilities that are excluded. Now the question is then, for us when we start developing, is how can we retrace these choices of how specific forms of knowledge are represented in order to then better understand these systems and how they enact people. And so to do this, we use these comparisons of data models because, as Analisa mentioned, so the meaning emerges out of this comparison. Now for this presentation, I wanted to explore an example, a new example that I could also, let's say, be useful for the audience as an example of just using publicly available data. And of course, given this current situation, I thought a good example would be travel in COVID times and the various passenger locator forms, which some of you may have had to fill in by now, and which have also been previously discussed by Claudio Coletta in his very interesting presentation. So these kind of forms are used by health authorities to facilitate contact tracing in case travelers are exposed to some kind of infectious disease during their travel, now COVID or something else, of course. And I thought it could be an interesting example also to show you, because they are somewhat standardized, not very, and every state also seems to have created their own in this year. And so we can use this as an example to explore how people are enacted as travelers through these forms, or potentially risky travelers, infectious. So the first step in using this method, of course, is collecting some data. This is usually related then to some kind of fieldwork or desk research. So in the processing citizenship, we use various data collected by our team members. In this example, for example, we would use these passenger locator forms, which are available on the web or on paper. And we can use these then to compare data models of, for example, these national and international authorities. One of the first difficulties then is that all these forms and data models have their own way of defining the kind of people that they represent, and they're not immediately comparable. So to give you another example of what I'm talking about, these are the kind of forms. So they can just be PDFs, or they can be web apps where you have to fill in your information before you travel, such as just your personal information about your flight, etc. Some are in more machine-readable forms, others are more in different forms, like this one of the Italian, which reads almost like a contract or something. And so one of the first steps that the Ontology Explorer aims to tackle is how can we make these kind of various formats comparable. And for this, so we devised a structured approach to do this. So the first step to make this data comparable is through data coding. We use a qualitative analysis tool for that. Atlas TI. We divide this data coding also in several actions. Coding, well, preliminary in vivo coding, harmonizing codes, grouping documents, and categories. And as I mentioned before, these documents reporting these data models can be very diverse. They can be forms, they can be regulations, they can be design documents, they can be screenshots, can be data from interviews. In the PC project, we are using various things. So to give an example of how it would look, this coding system. So on the top, you can see this would represent one information system. We have information about the data model in different kind of documents, like it could be an actual database schema, but it could be an interview, it could be a screenshot. Within these documents, we have evidences of the categories of data, which we will code. With in vivo, we mean that we use as labels for the coding, the ones that are used. And in order to cope with variations that occur among different documents about the same kinds of categories of data, we introduced kind of code harmonization to group very similar categories of data. So in short, that will look something like this. So at the top, you can see, for example, a passenger location form that was introduced by the WHO, International Civil Aviation Organization, together. There we would code all the different kind of categories of data. So we basically label them with the name of the category. And at the bottom, you can see then, for example, if we would have something like flight number, route number, we could group this all together in one, let's say, meta category, which would allow comparison between different data models. Now, how can we start to analyze these data models? We focus on 3 analytical categories. First, presence and absence. So with this we mean whether category or value is used in one system may be present in another, is one set of questions we might ask. Or whether some categories are native or peculiar to specific systems. It's another set of questions we might ask. Or we might focus on frequency, such as which systems specific categories and values occur more or less frequently. So to make it a bit more concrete, I will first give a small demo in the tool and then come back to how it functions. So normally you should now see my browser. So this is a live version on the website. Here I would upload the project file from the qualitative analysis tool. Or I also prepared this sample project about the passenger locator forms. So once this is loaded, I could start asking, for example, questions such as, okay, I have a sample. I didn't, of course, code all these forms, but I took a few that are close to me. So if I would ask, for example, what is the categories of data that are particular to the data model of the Belgian passenger location form, then I might see, for example, that it's compared to Germany, Italy, or Netherlands, it actually contains some data about travel document information or duration of stay, which is not included in the other ones. And let's say, for example, a similar question about the Italian we could ask. There we see that this is the only one that actually takes into account some kind of address for self-isolation, and even actually takes into consideration in whose care you will be during that self-isolation. Or it also takes into account more peculiar routes of travel, such as a personal vehicle. We could also, for example, see the kind of data that are shared by all of them. So we might be interested to see which kind of categories are shared by all of them. And then we see kind of personal information or contact information is shared. We can also display this as a network, which already gives the same information. It's probably a bit unclear and there are a few overlaps, but this gives a similar visual overview. For example, we can very quickly see that actually the Netherlands is the only one that has something about health systems, or the WHO is the only one that has emergency contact information. So how did this actually work in more detail? So the operationalization actually works by making use of graph theory, co-occurrence analysis, and graph visualizations. So we create a network with nodes and links to represent occurrences as connections between different nodes. For example, a link between a node for the document of the passenger location form of Belgium and the node of the flight number means the category flight number occurs in that document. And so we create a complete network of these kind of nodes and edges. We do this in 2 steps. It's a bit programmatically, but so in the first we create very direct links. So for example, a category is present in one document based on all that coded data, or a document is present in a kind of document group, category is present in a code group. So you can see these different colors represent different kinds of nodes, actually. So you might have one schema that talks about surname and place of birth, and they're all linked to a kind of meta code group. Then we can also derive some indirect links, and together with this network then allows us to start answering these questions which I showed you about the presence, absence, frequency of kind of categories of data. So the operations that I used, which I didn't explain during the demo, is basically that they are grounded in set theory, because as you might remember, graphs and networks are, of course, sets, just a set structure with objects that have relations between them. And so for the ability to trace the invisibilities and silences through comparison, we use this kind of set and graph theory to compute these insights. So these analytical categories of presence, absence, we translate it into set operations on the elements in the network. So using the operation from set theory on our graph model allows us then to analyze this complex relationship of presence, absence of categories among these different data models. So if, for example, this represents a set of one data model, and this represents a set of all the data categories of another data model, well, the union is just what is present in all those data models. The difference would be this part, so which are only included in this data model. So we exclude this, or we might be interested in which are included in both of these data models. And then I also showed you the data visualizations. So this allows us also to make some kind of qualitative observation about the relations and the structures in the network. They can, of course, become also too complex, and then we use more mathematically defined measures to indicate kind of significance of nodes in the network. To do this, we use force-directed graph drawing algorithms. So in short, they use a kind of model from physics that positions these nodes. So the network that we made doesn't have a visual representation per se. They're just sets and links of nodes and edges in between them. And we create a visualization by positioning these in a space. And they are pulled together, let's say, through force of attraction and repulsion. And we also, for example, draw some nodes closer together because they share a very similar name. So that's based on string similarity. So the previous this metaphorical spatial representation from the visualizations can also be expressed numerically through a concept of centrality. In this case, that can be an indicator or measure importance of nodes based on a number of links it has. There would be degree centrality, and we could say high degree centrality just means or indicates that this category are used often by multiple systems, or low degree centrality, it is quite particular to the system. More complex measures of centrality are, for example, between the centrality, which actually comes from more study of communication networks. It identifies important nodes based on their role in the flow of information in the network. So in that approach, the importance of a node can be derived by the number of times it can be considered to form a bridge and potentially connect two or more systems. That could indicate kind of nodes that might be important if one would connect different systems. Okay. So in the final part of the presentation now, I will discuss some of the illustrative uses and assessment we've done for the Processing Citizenship project, and also some thoughts and reflections on the method itself. Andrea, I lost how much time I left because I had to switch, so you definitely have to.
Yes, so I would say 4 minutes if you deal with it.
Okay.
But we can also
Be flexible.
yeah, we can be flexible with this session, of course.
Okay. Yeah, but some things I can maybe combine then in that case. So in the Processing Citizenship, we ask questions which then relate to how people on the move or migrants are enacted and represented by national and European authorities, and also what these kind of enactments share. I will come back to this later. So, okay, just quickly, of course, we look at very different data models in this case. So we look at, on the one hand, EU databases, for example, Eurodac for asylum, Schengen Information System, which is about security and border management, or the Visa Information System about EU visa policy. And we compare these to national systems based on, so the previous was more desk research, and the data that we have is based on regulations and these kind of documents, while national systems, we have very diverse kind of information about these data models. So we have, on one hand, for example, the Hellenic, the Greek Register of Foreigners, where we fieldwork on the reception centers in the hotspots, and the German Registry of Foreigners, where we also have data. And so by following these methods, we, so again, we also coded it, we create a network, we run the analysis, etc. We can start to look at how we can answer these questions. So this table sort of summarizes these results of this analysis for determining presence and absence of categories. So this is just an excerpt of the table, but it can show, like, for each code group indicating if it's present or not in the authority. So we combine, let's say, these 3 EU information system as one authority, and we compare this to national authorities. So that's also one of the strengths of the system, strength of the method, that we can actually do this. So we can sort of analyze them as if they're one. So we can set these authorities as independent variables, and then see the categories and code groups present in the data models. And this allows us then to really pay attention to what is basically not included. So in general, of course, the authorities can differ in the type and granularity of data they collect, and the amount of control the system allows in adapting for local circumstances. So these kind of differences also help us further analyze how, for example, migrants are enacted as persons in need for integration. For example, a category only included in the German Registry of Foreigner, or how migrants' family relations are enacted. For example, the Hellenic Registry of Foreigner seems to focus much more on parents' data. It also includes more about children. The German Registry of Foreigner is also quite expansive in terms of family data, so children, parents, spouse, life partners. And for EU systems, and these kind of data are not present. But at the same time, we can also, of course, see some consent in the way they enact with migrants. And within these consent, then we can use the centrality to reveal that some categories may be more important, possibly, than others, such as date of birth, nationality, which are shared really between all those systems. So in general, we also came up with some benchmark criteria in order to assess our method in terms of making infrastructures for identification of people on the move visible. So we have some criteria such as comparability. I talked about how the method allows to compare very different data models. Visibility, so it allows us to see which kind of categories are present and absent. For example, some national systems have data that is not included in others, such as family status, temporary accommodation. This then tells us something about how they are enacted. We also can see granularities, differences in granularity in the categories of data. For example, one system might have very basic information about names, other more earlier other names, etc. Or how different how people's data are linked across systems, how they might exist in different locations, but then are linked together. How certain categories of data are aligned, for example, temporal alignments or roots, and also the kind of control that sometimes is allowed, such as we're talking about language, if it allows mother tongue communication, language other, which is sort of shows that in some kind of situations there would be still some control for the persons filling in.
Wouter, could you please go towards the conclusion?
Yeah.
That we can take 10 minutes for the Q&A.
Okay, I'll just finish with this one. So in general, some caution, of course, has to be taken in interpreting these results. And so we also, following Venturini et al., we reflected on how network and visualizations should not just show connected complexity, but also help us, how can it help us understand the structures of the networks. And then it's interesting that also sometimes the ambiguities in network analysis and visualizations can be considered a strength, as it can encourage further and deeper analysis on the ambiguity of the empirical data that we collect as well. And so the method also then is supposed to support this discursive analysis of information system ontologies and data models. And finally, we also see our approach as a kind of assemblage of different methodological approaches and traditions, what Dr. Maulis and Calvin Kerlitz call interface methods. And this also, I think, is interesting to because it urges us to pay close attention to the process of using all these different kinds of methods, so discourse analysis, network analysis, and also how these kind of tensions can be productive in the analysis. Okay, and that's all I wanted to say. Looking forward to the discussion.
Thank you very much, Wouter and Analisa. So I leave the floor to Professor Aldo Gangemi for the discussion. I would say up to 20 minutes or, yeah.
Yeah, thank you. I'm trying now to share my content. Is this happening? Probably not.
I hear you.
We can hear you well. You want to share your screen, maybe?
Okay, maybe it's happening. Yep. Can you see it now?
Yeah, perfect.
Okay, thank you. So let me project it. I just concentrated in a few slides. What I'm actually in this way, lose the ability of looking at you, but okay, I guess I can just look at the presentation so you can read the slides better. So firstly, I would like to stress the impression, the definitely positive impression that I got from this, from the Ontology Explorer and in general from the workshop today. So then I am partly far away from this community, although I have a past as a philosopher. Then I became a computer scientist, and I kind of mixed the two natures of mine. But let me say something in order to tell you why I will tell the things that I will tell. So firstly, I am co-founder of the Semantic Technology Lab at the Institute of CNR, where there are great people like Giulia Andrighetto, and which I actually now directing. And the idea is that this lab is working on computational ontology design, automated knowledge extraction, and vertical applications in these technologies in cultural heritage, public administrations, etc. So also this is recently connected also to other initiatives at the University of Bologna, like DARC, the Digital Humanities Advanced Research Center, and the ALMA AI Artificial Intelligence Center in Bologna. So say that these are some things that we do. So there are references that you can look at if you want to know more about how we do ontology design patterns and ontology design in general. There is a book, and there are some projects of knowledge extraction, like Fred, which is one of our frontline projects. And there is this ARCO project that managed to use these knowledge graphs, linked data ontologies for the entire catalog of cultural heritage assets in Italy, where something happened there. So that's some background in order to give an idea of what we do and why. So my first impressions about the Ontology Explorer, as a method actually, and also as a tool. So I think I'm impressed. Okay, I'm impressed because it looks like we are dealing, and when I say we, I mean you and my lab, are dealing with a recurrent cluster of problems that deal with data modeling, with how they are conceptualized, and about what knowledge patterns could be used or emerge out of those analyses, and also about ontology in general. And indeed, there is something different in the way you use the word ontology, which is not different in our field, but we use ontology also in a computational sense, which is not what you do. You mean by that you mean data modeling. By the way, when I saw the requirements, theoretical principles, solutions in Ontology Explorer bear also some substantial similarity to our field, which includes things like the semantic web, linked data, knowledge engineering, etc., knowledge graphs. And there are things that are not so often considered in our field. For example, high-level performative social semantics is mostly unexplored in our field. We are doing something there in the SPICE H2020 project that started 1 year ago that deals with data-centric, ontology-intensive methods for social inclusion, both for and via cultural heritage experience. There actually encountered a lot of problems in interpretation and reflection and what you call performativity of knowledge technologies that might actually impact in the way people react, the reaction of people, like Analisa mentioned before. So this is the idea of resistance, or emergence creeps. This is really super interesting for us because for a long time we just focused in the community on use cases that are a bit more manageable. The semantics that is typically very relevant for sociology, for example, even for philosophy, cognitive science, etc. Also, I heard discussion about using both symbolic and sub-symbolic methods, which is currently a holy grail, actually, in artificial intelligence. So kind of hybridizing that, it's not that easy. I mentioned here the Taylor Excellence Network, with which participated, actually there are more than 50 participants across Europe, that tries to address this general problem. So, by the way, my conclusion in the first impressions is that Ontology Explorer is a great case study for the knowledge graph community. And there is, I have a personal interest, by the way, in reusing graph-based data sets and trying to understand how we could actually compare what you did, in a sort of you tailored actually your application so that it works fine with problems that you even spell differently from how we do, but actually have a notable degree of similarity. So I will tell you this in a bit more detail, provided that I have all that time. So these are typical problems that we have. This is in Italian, but there are no very stupid problems like Rome and Milan use two different accommodation schemas in their databases, and you have all the problems that you found in questionnaires and forms that you are analyzing for the databases. So you have the problem of understanding if there is something that is missing in one or present in the other, or the opposite, or if they overlap or not. So if there are gaps or things like that, like those, and they are spelled differently in their names, and even if you look at the data, are not so easy because they are formatted differently. So this is a clear problem that is traditionally called and very well known also on the level of European Community framework projects, is the notion of semantic interoperability. Okay, for example, the CEMIC agency of the European Union deals with that, trying to enforce or to propose vocabularies and to be reused across different systems, heterogeneous systems in the community. Another example is learning from cases. No, you talked about variety, and so sometimes people react. Okay, but the interesting thing of this case is that people
a Riccardo piace ascoltare il suono del caffè che sale dalla moka, e da quando ha scoperto le nuove nastrine al cioccolato gli piace morderle prima da un lato, poi dall'altro. Fragrante pasta sfoglia e cioccolato nelle nuove nastrine mulino bianco.
No telephone number, then I just use the email because it's the closest.
Io sono Andrea Mattia,
the closest to what I want to express.
Giovane,
or there might be some logical
che ho aperto la mia attività.
Vivo
solo di quello. Questi anni ci sono stati molti bassi e pochi alti a livello di produzione miniere, dovuti soprattutto a due fattori: la mancanza di ambienti puliti dove le api possano riprodursi e vivere, portare miele nelle loro casette, e l'altra è l'uso di nicotinoidi, pesticidi, diciamo, per capirci. Ogni anno si inizia sempre con tante aspettative, con tante difficoltà, ecco, quest'anno sembra che iniziare a vedere un minimo di luce, ma niente, la luce è praticamente scattata stamattina quando mi hanno chiamato da posto a 2 ore da casa mia, dove io avevo curato le api per la fioritura della caccia. Nonostante tutte le gelate che sono verificate in Piemonte, quest'anno ho deciso di portarmele a 2 ore di distanza, con enormi sacrifici, chiedendo aiuto anche agli amici. E stamattina alle 6 il proprietario del fondo mi ha chiamato e mi ha avvisato che qualcuno stanotte si era preso la briga di andare a rovesciare le casette.
And by the way, you may
not
know they are related to causality aspects or epidemiological ones or legal constraints concerning patient histories. Similar problems arise also.
Sto andando un posto bellissimo dove ci sono anche dei laghi stupendi, incontaminato. Purtroppo non è incontaminato dalle brutte persone, dalla cattiveria delle persone. E mentre dico cattiveria mi viene da piangere, perché non si può pensare di trattare così male degli animali, cioè, rovesciarli, farli cadere per terra, stare tutta la notte fuori dalla casetta alla pioggia, o ad aspettare quello che vedrò, e quindi niente, sono sicuramente preoccupato e deluso dagli sforzi che uno fa, sforzi di anni e che purtroppo vengono vanificati. Io sto arrivando poi nell'apiario,
from semi-structured data like tablets, catalogs,
tesoro,
or even from unstructured.
Ho avuto tutto ieri, tutto oggi.
Text. And And there are methods for aligning them, so for dealing with comparison, etc. No? And so my first impression after saying, come on, these guys were great, actually. Managed to create an XML-based semantic interoperability framework tailored to their problem. But I would like to collaborate with them. The second impression was, okay, but come on, why don't we just augment the possibility that you have by using your datasets also in context where you can reuse an impressive amount of research and results that have been produced. So going very quickly. So what do I say? I summarize this in 3 slides. Hopefully I have the time to deal with that. So the first one is what do you mean by ontology? Possibly you mentioned it, and your general requirements. So how do we talk about populations? Or there are heterogeneous ways of profiling communities or even people, or classifying, etc. So there is this distinction between visible and invisible.
A Riccardo piace ascoltare il suono del caffè che sale dalla moka, e da quando ha scoperto le nuove nastrine al cioccolato gli piace morderle prima da un lato, poi dall'altro. Fragrante pasta sfoglia e cioccolato nelle nuove nastrine mulino bianco.
In terms of semantic technologies. And also that things that are not well known, like even comparative ontology to catch these comparative aspects that you have mentioned, that include also epistemological decisions that are not often considered in our field. Actually, just if you look at was commenting separately that your comparative approach is something that we happen to discuss as well when comparing different theories that describe the same phenomenon in different ways, and how to do that. Okay, so basically we have set theory-based, theoretical operators that work as similarly as you do with graphs, but augment them with logical constraints, etc. And also another problem that is very interesting is the performative effects of knowledge technologies.
A Riccardo piace ascoltare il suono del caffè che sale dalla moka, e da quando ha scoperto le nuove nastrine al cioccolato gli piace morderle prima da un lato, poi dall'altro. Fragrante pasta sfoglia e cioccolato nelle nuove nastrine mulino bianco.
For that is the fact that you use this ontology versus data model distinction by using the Saussure Lang versus Parole opposition. At least this is what I got from a draft that Analisa kindly sent me a time ago. The point is that in ICT, this is important in order to talk between separate different communities. And ontology is what you mean by ontology, but it is also an artifact called the computational ontology, which is closer probably to what you mean by data model. And the idea is that, by the way, computational ontology is assumed to be grounded in reality. And this is done, reality, of course, considering any kind of reality. Okay? There's no particular fixation on a variety of realism. Because it helps approximating the form of the data to what they are supposed to denote. And this is something that you kind of distance yourself from, no? Because by using just XML and the system that you have created a system that has very good semantics, as I've seen in your presentation and the draft. Yet this is not something that the machine process unless you create this tailored, very focused and intelligent approach. In XML you can do whatever you want, basically. Okay? There is no constraint from the logical and semantic and sense of formal interpretation of the data. Actually, doing with that is maybe a step beyond, but helps you add in a lot of automated reasoning and other things like that. Sorry, how many minutes should I have? So I decide what to present and what not.
Sorry, 3-4 minutes, but we can be flexible. So.
Okay, so I can. They're a bit dense, but I will try to summarize them. So another analysis that I did is trying to understand your principles that for me are more or less functional requirements in ontology design. And it's ontology design in the sense of computational ontology design. And they are, by the way, they are close to things that we do, basically. Just to make some examples, comparability for us is already done. There are techniques for doing that. No? So there are things like ontology matching, or linking to more general theories, or trying to link to existing cognitive frames, or dealing with concepts that are open textured, for example, in the legal field, or even this area that is we are working on as comparative epistemology in ontology. Also, visibility, no, is the idea of making things emerging in order to establish if, deciding if a concept is missing or could even be incompatible. No? This can be done automatically, because if you use this axiomatic approach, you can decide if something is compatible or not across two different systems, even if they have the same name. Of course, this has a price, of course, no? Because in order to do that, you have to close your axioms. And then you are a bit less open to possible open textured interpretations. Then you may want to relax your semantics in that case. By the way, I don't want to become too technical, but this is something that we also have as a problem. Also having a different detail, no? Like in granularity issues, or creating grouping, no? Or entire patterns. This is very interesting, no? Because you produce these use cases like creating, knowing that the passengers were on the same flight, no? Or members of the same family. Very nice slide, by the way, Analisa. So this is something that really it's interesting, and what I stressed a lot of times, but wasn't really considered much in the community, is that a lot of semantics is hidden in the interface, not always only in the data. So often the systems themselves have a way of integrating the data and showing them in a certain way that is based on some important knowledge patterns for the domain, and then you have to take it into account. And so, okay, these are some examples. I don't continue to that, but there is this the principles you provided is an example of what you did starting from your problem, your domain. So it's a great set of functional requirements that in some cases have already some automation in our domain, others have not, and are interesting to explore. Also considering the solutions, and this is the last one. So for example, document grouping, no? It's something that let us understand association patterns that are based on the interface, what I was just saying before. While the presence absence issue is something that you can calculate, you compute automatically by using the set theoretic closure within knowledge graphs, by using linked data, for example, the RDF and OWL. Frequency is also analyzable by launching queries and establishing the cardinality and the average cardinality of concept extensions. But okay, this is just for technical things. So, okay, to conclude, so basically you did a great application just using pure graphs, and you created concurrent networks using the degree and between centrality, etc. And actually what you did actually seemed to you have created a sort of intentional view on heterogeneous database schemas, which is something that we do in multiple different ways, but you implemented in another one that does without using actually all this very complicated apparatus, which is in principle quite straightforward solution. On the other hand, what I'm proposing is that you have the ability of preserving what you did, but also using knowledge graphs that actually you can apply to knowledge graphs also the graph-based methods that you are applying, because they are very expressive graphs, but also gaining logical and computational ontology ones. For example, axiomatization could help clarifying alternative conceptualization. You could use the web as the referentiability platform for decentralized interoperability. You can use existing solutions like design patterns that deal with modular interoperability and perspectival framing. And there are methods for automatic extraction, tools to disambiguate vocabularies, and also, these linked open data that are what is behind this knowledge graph movement. And the fair data, for example, is another way of describing the functionality of this linked open data are in the spirit of EU. So you know that this probably you know that, no? This was publicly endorsed by the European Union at the top level, actually, during the inaugural discussion of the President of the EU. So there is a commitment to using these approaches. And this is pretty easy for you, actually, starting from your existing platform. So this is my suggestion, and of course, then I stop here, and possibly you have something to tell me, just how you there, or something like that. Okay. Thanks.
Thank you very much, Professor Gangemi, for this very rich presentation. I think I would immediately give Wouter and Analisa the chance to react to the many comments and issues. But yeah, for those of you who have questions, you can either write them in the chat, or you can have some time left, I think, for the Q&A later. I think we can finish 5 minutes later than expected. So yeah, Analisa and Wouter, I don't know who you want to
maybe I can start quickly and then leave the floor to Wouter. Thanks, Aldo, for this semantic interoperability exercise. Basically, that's a meta exercise you did. I think you probably also spot the let's say different souls that converged in this project. And Wouter will definitely, I guess, will say something more about the benchmarks or designing requirements, functional requirements. I just wanted to think aloud with you about the obvious difference between what you're doing and what we are doing. So you said we build on reality and try to approximate as much as possible to the real world. While in our case, we try to use that reality or that approximation to reality as our data to be analyzed. So it's kind of a meta analysis. What we are trying to do, what is part of our goals. But at the same time, I think that this is the moment, and that partly emerged also with the discussion with Norti, Julia, and Elena. This is the moment where these two, let's say, goals, these two aims, of one hand representing, and the other hand discussing the representation in a meta way, let's say. This might be the moment when they can really find ways to be to mutually contribute to each other. One way might be to save some work to us instead of using, as you suggested, some existing tools like perspective framing, and of course we did knowledge graphs. The other way might also be to ask how do these methods interact with us as researchers and with the reality that we are representing, which is the topic of the previous roundtable. But I'm pretty sure this is also the historical moment when this approximation exercise and this meta exercise of description can learn from each other. So, thank you.
Thank you, Analisa. You expect that I answer, or expect I wait for?
Well, I don't know.
We don't have much time. I would say maybe first, Wouter, if you want to add something.
Yeah.
Let's see how much time we have.
Yeah, just something short, I guess. There's a lot in your presentation. Thanks so much for that. Really, quite
I tried to be helpful. So
I think definitely. Yeah, it's brilliant, this meta perspective that you can take and to link all these concepts together. Maybe a few things. Yeah, I think in general, our method has become sort of very idiosyncratic. So I understand also sometimes perhaps we are not making use enough of some methods in ontology engineering and knowledge representation. In some ways, because maybe we also have some differences in focus. Like some things are very manual in our processes, which also we have to make a lot of decisions. And I know that there are a lot of methods, for example, ontology extraction, I guess, and ontology matching that could automate some of these things. But at the same time, I guess we are not always looking for the definite answers or it is really like also a process of understanding these data models in a more qualitative and discursive approach. Yeah, concerning some of the namings, for example, I know are confusing. I know, of course, that ontologies have a specific meaning in ontology engineering, computer science. So we've always been sort of struggling with that, especially because we have to talk a lot to social scientists, which have a very different understanding. But at the same time, we do have, I guess, this notion of we want to have, I don't want to call it metaphysical or something, but we do want to see this kind of imaginations of different authorities and different institutions. Mm-hmm. And there is something shared between them. And these are though grounded in some material things, which then are the data models. So they do allow us to recover this kind of also shared understandings of who are migrants, how should they be represented, etc. So I'm not sure how that exactly fits with the understanding sometimes in the more computer sciencey aspects. Although of course I know that they sometimes have the more engineering, I guess, approach of how do we represent people and how do we make these choices, while we do the different direction, I guess. Yeah, I think those are some of my thoughts that came up.
Maybe Wouter, you could just say that the Ontology Explorer is going to be released open source on the website?
Yes, there is already a link, definitely, that you can use with that test project. I will link it in the chat. And it will also, the source code will also be released, of course.
Okay, we have time for a couple of quick questions maybe, but we can continue this super interesting discussion during our virtual drinks, sorry. But yeah, first of all, yeah, Norcha, I see.
Yeah, it's really great to see this work and this method deployed in your project on this really challenging topic. I mean, I've always been both surprised and then inspired by the move to apply correlational methods to analyze models. And you know, I think it's really quite different from how sort of associationist ontologies are usually operationalized in sociology of science and technology. So I think it's really exciting. I have a question though about this project in comparison to earlier work by Analisa, because I know the work that she's done on using similar methods on analyzing the Ars Electronica database of media art projects or digital media art projects. And I was struck by the differences between that material and the current material in that, you know, there's a lot of heterogeneity in the media art scene and in the digital culture scene that you know, let's just say it's sort of lacking when you're working with bureaucratic forms. So it seems that your form, the model that you're working on is a kind of a homogenization engine, right? I mean, that's what the form does. It makes all these disparate, separate, diverse situations somehow comparable and fit in the same mold. And if your method is about reconstructing models and sort of surfacing heterogeneity as somehow critical to understanding the politics of governing population through and at the border, like I wonder, how do you account for that as your object methodologically? And then second, I was wondering, could that perhaps be addressed by including different sets of categories, like action categories? If you would, for instance, have the added category of admit, not admit, or, stay or expel, or like, could that bring the kind of heterogenizing sort of force into your database that would then make it perhaps more possible to do a heterogeneity oriented analysis?
Yes, it's true that the data set is quite different from previous work. At the same time, what I think we are trying to do by looking at, by comparing, is recuperating some kind of heterogeneity, because it's indeed, bureaucratic forms might be very thin, as I said. So you might have nationality and set of 200 nationalities as attributes everywhere. But this, of course, is not so interesting for us. So when it's this standardization, it's what we're trying to say, sieve out and to make the differences emerge. So, for example, one country, this is not a real case, but I can make just an example. One country, if we take nationality, one country recognizing Tibet and another country not recognizing Tibet, for example. So that's exactly, this heterogeneity is exactly what we are trying to figure out with this system, and ideally to expand it beyond Europe. So the culture, if you want, the cultural specificities that are political cultural, it's what we are looking for. The example, so how is the couple relationship? Wouter showed the example of the different attributes for a couple in the Greek system and in the German system. So that tells a lot about the way the Greek government and the German government look at coupling relations. So that's the idea of, while we try to understand how people are enacted, it's also a way to look at the differences, the heterogeneity among polities or among institutional actors. So that's exactly the goal that we are trying to do, to see some difference in these otherwise really homogeneous, thin governmental bureaucratic forms that in the end they are not all the same, and they can tell a lot of differences, not only between member states, but also between member states and European agencies. So this book chapter that Wouter and I are publishing now, it shows, for example, how the European systems like Eurodac, they collect very little data about people. They're mainly indexes, while the Greek system collects really a lot of personal data, including profession, language spoken, etc. That corresponds to a division of labor. That's quite clear. It's a division of labor between frontline member states who collect types of data that are supposed to that enact the migrant as a long-term resident. So, you know, their title, their study degree, their previous profession, etc. And this is made by design impossible at the European level, because that data is not passed through the European systems, and therefore other non-frontline member states don't achieve that data. So that's a clear division of labor by enacting the person as a long-term resident, or enacting the person as a potential criminal, like in the case of, or as an asylum shopper, like in the case of Eurodac. So yeah, that's what we're trying to do, to recover this heterogeneity, also in, if you want, the geopolitical terms.
There's another question from Toon, and then probably we can wrap up. And
yes, just a short, and maybe I've missed it, but I was wondering, maybe also with the transition to tomorrow, it looks super interesting, and I wondered who, in terms of the scripted user, are there other users than sort of the people in this room, except who we had this morning, Sebastian, I forgot his last name. Are you exploring as well what it could mean in the practices of designing these? What kind of use beyond the walls of the academy you have envisioned, or are experimenting with, or hope to experiment with?
Yeah, I think at the moment we are sometimes maybe still too focused on our audience, but I think it does, or it can definitely be useful in terms of data interoperability, semantic interoperability. Also, in terms of domains, it is really not specific to migration and border control, for example. It is just a method that can be used to compare data models.
Yes.
And
yes, but it's also not, of course. We spoke a lot about its formativity, so obviously it will have that in various forms. I was just wondering, I mean, I've been thinking quite a bit about the struggle that Sebastian mentioned this morning, about, he's aware of the problems of the exclusionary performances that come with securing anonymization. And I guess I could imagine, but I don't know this field very well, so I might be very optimistic, but I could imagine that there are sort of, lack of a better word, smart actors in this field who are aware of the problematic exclusionary performativity of what they try to do, and it could be, I would envision, quite interesting for them to see how what these different ontologies do. I'm not sure they would speak about it in those terms, but I'm very curious.
We are launching the system today, so we hope that it will be performative with this kind of users.
And I'm sorry I didn't give Aldo Gangemi the chance to reply. I don't know if you want to add something, Aldo.
No, I haven't much to reply actually. So that's great actually that there is a chance for possible collaborations. Also, imagine when I say that about an intentional level of that you are addressing is exactly what you mean by meta actually. So you were kind of looking at the meta level, and the interesting part, as I already said, is that you are also trying to catch the actual impact, the performative consequences of these technologies, and this is something that is definitely of great interest to the community in general, and I am particularly interested in that. So, if it's a potential use case that considers also that and the possible extensions by using also our own technologies might be interesting. I'm not saying tomorrow, of course, but this could be has a great potential. So thanks again for the very interesting delving into what you do in this community. Great.
Yes.
Thanks.
Thank you, Aldo. And as we were saying, the system is published on the Process and Citizenship, so it's like okay. Wouter has posted it. So it's please also to the other presenters and participants, feel free to test it and to let us know what you think and what you can do also. It would be very nice to have stories about using this tool to post on our website. And so tell us your story, please.
And don't hesitate to contact us. I mean, some things are still idiosyncratic and need some work, let's say, in preparing data sets. But I think what I also wanted to show, for example, if you follow the methods, and I did it for these passenger location forms, something that's very new, can actually be done very fast and can be interesting in a lot of fields. So I hope it will be useful.
Okay, so thank you very much to all of you. And I think Joren, are you there? Yeah, so please explain us how these virtual drinks are going to take place.
Yes. So in the chat, I dropped a link to our Arium room, which we created for this event. Normally, well, I wouldn't say the most fun, but definitely in the top 3 of fun of conferences is the drinks. And we always found that online events don't really replicate that feeling so much. And with Arium, which is a platform that we find that it has the most of what makes the informal section of a conference fun, which is the possibility for kind of serendipitous interaction. So if you click on this link, you will go automatically into the room. You only have to write down your name and accept the use of your webcam and microphone. And there it will explain itself. It is a 3D room in which you will be projected on a sort of stickman figure, and you can walk around through the room and people around you can hear you, but not everybody, only people in your area. So in this way it mimics a natural conversation. Keep your battery charger close by because it does take up a lot of your battery. And make sure you're out of Teams first, because using the two at the same time is much too much of your internet. It doesn't work so well. So once you go there, make sure that you have your Teams off and a drink nearby. I already have mine. And yeah, make sure that you are audible the moment you come into the room. This is especially important for the people in Bologna right now, that they don't get feedback from each other. The rest explains itself. It moves around with the arrow keys. That's all. I will see you all there. The link is in the chat. You only have to click. All you have to do is click.
Yeah, over there.
See you in the other room.
I'm just going to take some water because I'm...
Wine is.
Ce l'ho dentro? Io lo do.